Hey developers, welcome to Devcovery. Today, we're bringing you the hottest open source projects trending on GitHub, so you don't miss any tech developments worth your attention.
Today, we're taking a deep dive into a trending project on GitHub, airllm. This project is turning heads by making the seemingly impossible possible, running a massive 70 billion parameter language model on a single 4 GB consumer GPU. It's a game changer that dramatically lowers the hardware barrier, putting powerful AI inference within reach for developers and researchers on everyday machines. What if you could run a massive language model, one with over 400 billion parameters, on a computer with just 8 GB of video memory? A new project suggests this is not science fiction, but a clever engineering trade-off that redefines the limits of consumer hardware. The project is called airllm, and it was developed by lyogavin. Its goal is to tackle the immense memory requirements of large language model inference. It dramatically reduces VRAM usage, so much so that it allows models with 70 billion parameters to run on a single GPU with just 4 GB of VRAM. The developer community has taken notice. The project has gained significant traction, accumulating over 15,850 stars on GitHub, with more than 260 of those added in just a single day. And with over 1,600 forks, it's clear there's strong interest in its unique approach. So, what's the big problem airllm is trying to solve? It all comes down to one primary barrier when running large language models locally: video memory, or VRAM. A 70 billion parameter model, for example, typically demands over 140 gigabytes of VRAM. That's far more than what you'll find in any consumer-grade GPU. The standard solutions usually involve some kind of compromise. You could use techniques like quantization, which reduces the model's precision, or distillation, which creates a smaller, less capable model. The only other real option is renting expensive hardware in the cloud. airllm sidesteps this entire dilemma. Instead of shrinking the model to fit the memory, it gets clever. It manages how the model uses that memory, trading disk speed for VRAM capacity, all without a mandatory loss in precision. So, how does it work under the hood? airllm's architecture uses a technique that's a lot like on-demand paging, but for model layers. Here's the process. First, it pre-processes a large model, splitting it into individual layer files that get stored on disk. Then, during inference, only the single layer needed for the current computation is loaded into the GPU's VRAM. As soon as that calculation is done, the layer is immediately unloaded, making space for the next one. Think of it like reading a very large book one page at a time, instead of trying to hold all the pages in your hands at once. Now, you might be thinking that constantly reading from the disk would be slow. To deal with this performance hit, airllm uses two key optimizations. First, there's prefetching. It loads the times next times layer into memory while the GPU is still busy computing the times current times 1. This clever overlap between I, O, and computation helps hide the latency. Second, it offers optional blockwise quantization. This compresses the layer files on the disk, making them smaller. Smaller files can be read and loaded much faster, which directly tackles the main I/O bottleneck. This approach opens up a world of possibilities for a wide range of users. AI researchers and students on a budget can now experiment with state-of-the-art models right on their personal computers. Independent developers can build and prototype applications locally without racking up high cloud computing bills. It even makes offline, on-device inference possible for privacy-sensitive applications running on high-end laptops. And getting started is designed to be straightforward. The project can be installed with a simple pip install command. It also provides an auto model class that functions very similarly to the one in the popular Transformers library. This means developers already familiar with that ecosystem will find it easy to adopt with minimal changes to their code. But despite all this innovation, airllm is not a silver bullet. There are trade-offs to consider. First, its performance is fundamentally tied to disk read speed. This makes a fast NVMe solid-state drive a practical requirement. Trying to run this on an older mechanical hard drive would likely be unusably slow. There's also a potential maintenance challenge. The project's design requires specific adapters for different model architectures, and as new models are released all the time, keeping up could become difficult. And finally, its deep integration with the internal workings of other libraries makes it potentially fragile. An update to one of those upstream libraries could break compatibility, creating a real risk for long-term projects. Ultimately, the true value of airllm isn't about being the fastest solution out there. It's about being a times possible times one. It cleverly reframes the VRAM problem, turning it into an I/O problem. And in doing so, it democratizes access to massive AI models, making them available to anyone with a modern computer and a fast solid-state drive.
That's all for today's Devcovery. We hope these GitHub trending projects spark some inspiration for your development work. You can find all the repos mentioned in the description below. If you enjoyed this episode, don't forget to subscribe to our channel. See you tomorrow at the same time.